Chapter 14 Deep Learning Part 2 In the previous chapter, we learned what deep learning is and the basic structure of artificial neural network. In this chapter, we will see how to train a deep learning model and how to prevent overfitting. By the end of this chapter, you will be able to explain backpropagation, the learning process of a deep learning model. Explain how to optimize a deep learning model, and explain regularization methods used to prevent overfitting. First, let's talk about what a neural network learns and how to train neural network. As we saw, in a neural network, the calculation proceeds from the input layer to the output layers. This process is called forward propagation. You can see that, given the input values, the output value depends on the weight values. The input values are determined by the data. We cannot change the data itself. We can set and change the weight. So, how should we set the weight? The answer is that, first, we set the weight values randomly. In the beginning, we do not know the appropriate weight values, so we can set the weights randomly. Since the weight values are set randomly, when the network receives the inputs, the output value will be widely different from the actual value. That is, the network makes a poor prediction. But it is okay, because the neural network can learn the appropriate weight values from the data. Through the learning process, the neural network can find the appropriate weight values that minimize the difference between the predicted value and the actual value. Then, the neural network will become a good prediction model. The learning is implemented by a process called backward propagation that will be covered in this chapter. When we train a neural network in supervised learning, we need to split the dataset into training data and test data. We should train the neural network using the training data only. The test data must be set aside in the training phase. Then, after the model training, the test data is used to evaluate the model performance. We apply the trained model to training set and a test set, and compare the prediction performance. It is desirable that the model achieves high prediction performance both for the training and the test sets. If the prediction performance is much higher for the training set than for the test set, the model suffers a problem called overfitting. That is, the model just memorized the training data and is not capable of predicting unknown data. In other words, the model is not a generalizable predictor. So, we need to avoid the problem of overfitting and develop a model with high generalizability. Broadly speaking, there are two ways for use data for training. When we use all of the training data to train the model, the learning is called batch learning. But if the dataset contains a great many cases, using all cases of the training set requires much computational cost. So, in such cases, we can apply many-batch learning. Specifically, we can randomly choose a certain amount of data as a sample and train the model by the subset of the training data. Then, we randomly choose the same number of cases as another sample and train the model. As an example, suppose we have a training dataset which consists of 100,000 cases. In batch learning, we use all the 100,000 cases at once to train the model. On the other hand, in mini-batch learning, randomly selected 1,000 cases are used for training first, and then another 1,000 are randomly selected. This process will be repeated 100 times so that theoretically all the cases are used for training. Neural network computes output values by multiplying inputs and weights and adding them and biases, then transmits the values to the next layer from left to right in this figure. The output value depends on the value of weights and biases in the neural network. So, training a neural network model is a process of finding the optimal values of weights and biases. As I noted, since we do not know the optimal values of weights and biases, first, we set the weights and biases to random numbers. So, in a newly created neural network, the output will widely deviate from the true value. So, we need to train the neural network so that it automatically learns their optimal values. A neural network learns the optimal parameter values by a process called backpropagation. The process of backpropagation is shown in this slide. First, compute the output using inputs and randomly set the weights and biases. Then, compute the error between the output and the true value. Next, as the third step, check if the error was minimized. If the error was not minimized, update the weights and the biases. Then, compute the output using the updated weights and biases. Repeat the process until the neural network finds the optimal parameter values that minimize the error. Let's see a simplified example to get an intuitive understanding of backpropagation. Suppose a simple function that is expressed by the simple formula. In this function, the output is the simple product of the input and the weight. It is not a function of a neural network, but let's use it for simplicity. Suppose we have three cases. Each has only one input, so we have three inputs, 1, 2, and 3. Each case's true values are the following. First, let's set the weight randomly. Let's set it to 2. By multiplying 2 with the input values, we get these output values. Then, compare them with the true values and compute the errors. Then, sum up these errors. It is 12. This is the error to be minimized. Let's update the weight and set it to 3. Then, compute the outputs and the errors. The sum of error decreased. So, 3 is the better value than 2 as the weight. Let's update the weight again. Let's set it to 4 and compute the outputs and the errors. The sum of error further decreased. So, up to now, 4 is the best value of weight. Next, let's update the weight again, setting it to 5. And let's compute the outputs and errors. We can find that the sum of error increased from 2 to 6. So, the revision should be stopped and set the weight to 4 as the optimal value. In real cases, the weight is a continuous variable, and the process of finding the optimal value is far more complicated. Here, the purpose is to get an intuitive understanding. Thank you for watching. Please thumbs up and subscribe to my channel.